is regarding the Kia config backend. This is a new feature in the 1.6 code release, which is currently at its beta 2 stage and will be released imminently. The config backend is a scalable DHCP configuration management tool using a MySQL backend. So this is a really, really nifty tool, nifty ability to do configuration, and I think a lot of people will find it very, very handy and useful. So a little bit about Kia. It is a modern DHCP v4 and v6 server. 1.6 is to be released August. It is a high-performance DHCP server in the thousands of leases per second. Has built-in high availability. It has modules for netconf and radius as well. One of the things that it differs greatly from the ISC DHCP is that it actually has the ability to use multiple backends. There's a CSV backend, which is relatively similar to the log file backend of ISC DHCP, but then there's also support for MySQL, Postgres, and Cassandra. One of the other really neat features of Kia is the ability to use hooks. So if you have an extension or a modification to the way a packet is managed or a way a feature is handled, you can write a hook of your own. There are also a number that are available through ISC. If you ever used OMAPI for management of ISC DHCP, I feel very sorry for you, and I'm glad that we now have something much better. The REST API that's available through Kia has 120 plus commands that are available to you, and as you'll see today, the config backend actually adds additional REST API and through the hook mechanism, so you can extend it yourself for the commands that you need available to you. So the config backend really makes use of 3 of these features of Kia. It uses the database backend, which at this point is MySQL. It is implemented as a series of hooks, which I'll be talking about momentarily, and you actually are able to manage it through the REST API. So the concept of the backend system is that you have your DHCP v4 and v6 servers, and they have a number of basically databases, data stores that they can either keep locally, keep remotely, and keep in a number of different formats. So the first of the backends is the lease backend, and in this case, we keep all of the lease information for systems that are given addresses through DHCP, and they're stored into possibly a MySQL backend. You could also, again, use Postgres or Cassandra, but this is optional. You don't have to use an SQL backend. In addition to the leases, you also are able to keep host reservations. So a part of the configuration, depending on a specific MAC address is going to be given a specific IP address, that information can be kept in a separate database, also in a database format, and that is the hosts backend. Now, both of these have been available in previous releases of Kia, but the new one, and the one that we're going to talk about today, is the config backend. And within the config backend, we're able to keep all of the other bits of configuration information, including the options, the pool definitions, the subnet and shared network definitions, and then options and global parameters can be stored in this config backend and then made available to your DHCP v4 and v6 servers. This actually allows you to reduce the complexity of the configuration that is actually on each of the servers, so they can be pre-configured with a very simplistic configuration, and then the config backend can fill in the additional pieces. So what this config backend does, as I just said, it's the ability to receive the configuration or retrieve it from a database. And again, at this point, it is MySQL. The database stores configuration elements, and these elements can be the definition of a pool, the definition of a network, all of those things that were mentioned previously. The DHCP v4 or v6 server has a name that it knows itself as, the database can regarding elements that are available to that server name. The MySQL server can be co-located with a DHCP server, so it can be running both the Kia DHCP v4 server and the MySQL server, or it can be remote. So you can have multiple Kia servers sharing one remote MySQL database. So in this way, you can have multiple systems reading from that single database and able to get very specific configurations to themselves instead of just a one globally shared configuration. The database can be modified when the DHCP servers are offline. So this allows you to make changes in your configuration. If you have automated tools that are doing configuration management, they don't have to be able to write directly to v4 or v6 servers. They make a connection to the SQL server that is changed. The data is changed there, and then as soon as the v4 or v6 server is available, those servers read from the SQL database and deploy themselves as they've been determined or as they've been defined. You don't need to do server restarts. That was one of the things a lot of times when you were doing a configuration change on ISC DHCP, you made the change and then you killed the server and restarted it. Obviously during that period when it was being restarted, there was a possible, there was a window for leases to be, there was times that the server was not available to do whatever it needed to do. With the configuration backend, what happens is the servers are updated automatically. The information is, or the new configuration is applied without needing to restart the DHCP server. At this point, the model is a pull configuration. So what is done is on the DHCP v4 and v6 servers, there is a value set for the config fetch wait time. And that is the length of time between the server going out and seeing if there are modifications to its configuration from the back end. So at this point, if you make a change in the database, the remote servers are sitting there sometime through the config fetch wait cycle. And then when they wake up from that cycle, they go out, they query the SQL database, and then the changes are applied to your server. Again, why am I seeing this slide again? This is strange. I should not have seen that slide again. I apologize. So the ability to do offline configurations, the samples that I'm going to give today show clearly that changes made to DHCP v4 and v6 servers that are actually running on the SQL server, and the management is being done at the same time on the machine. You could actually split this now into multiple layers where you have a dedicated configuration machine where where you're actually doing the database modifications. Those database modifications are then stored into the MySQL database, which is, again, either local or remote. And then all of your DHCP v4 and v6 servers are somewhere out at the edges of your network. Again, this allows you to manage the configurations when the servers are offline. One of the big gains of this is to allow firewalling of your configuration management. So you configuration node in a secure network layer, and then have the connection between it and the MySQL server secured as well. And then you're able to control that very, very securely. Why would you ever want to do this? Well, there's a number of different use cases. In playing with it, I've found it to be a very nice way to manage even a very small Kia configuration because you're not having to worry about text files. The first of the use cases is the sharing of configurations between HA partners. You set up each of the partners as a client of as a configuration backend client of a MySQL server. You make the changes in the SQL database, and it is then pushed out to both of the HA partners at the same time. Again, you're not worrying about going in and editing text files, and you're sure that the same configuration or a very, very slightly modified condition is being sent out to all of the servers at the same time. If you have frequently changing configurations, again, even if you have only one or two servers, making changes out in text files out on machines that are possibly public facing, sometimes a pain. And so in this way, to make the changes in the database and have it automatically. I see this as a huge move forward in automatic configuration management, because having a front-end server that does basic error checking, basic knowledge. It has basic knowledge of the IP address structure within your networks. Being able to have that system push changes out to have the servers pull their configurations from this centralized database is a fantastic mechanism of automation. If you have large configurations where you have hundreds or thousands of networks, or if you have large deployments where you have hundreds of DHCP servers, this is going to be a great way for you to make changes on those in those configurations, because it's going to allow you to, again, have a front-end system that allows you to do something better than just go in and edit a text file. And again, with large deployments, being able to go in and make changes to multiple servers and have them deployed at nearly instantaneous times is a very good and useful feature. When you're scaling up or down, one of the things that you'll see in the rest of this presentation is something called a server tag. And a server tag is the ability for any object in the database to be associated with one or more servers. And in that case, you can go in and make a change to a server tag and have it then applied to different servers than it was applied earlier. So if you want to move a pool from one server to another, if that pool is defined and it has a server tag that points to one machine, server tag to another machine, it automatically then is removed from the machine where it was running and is moved to the definitions. Again, it doesn't move the pool itself. It doesn't move the data in the pool, but it does move the definition. So the new server is able to begin serving leases from the new pool. In addition to this, obviously, since it's a MySQL database, you have the ability to monitor the database, do reporting, do backups, any type of redundancy that you have within your own infrastructure over that SQL database. Obviously, you can go in and make changes to the database, and if you have your own tools and you don't want to use the configuration backend commands hook, you can actually go in and make the changes to the database yourself and have them automatically associated with your servers out in the field. So a little bit about the config backend and additional information. As I said previously, it is currently MySQL only. There is a plan to support Postgres in a future release. I'm not going to give any times or schedules for that, because that's well above my pay grade. But that is something that is being considered. At this point, only the DHCP v4 and v6 servers can be modified by the config backend. The D2 or DDNS configured the server is not at this point able to be controlled by the config backend, as is the control agent itself. So you're still going to need to manage those specifically. Also, other hooked configuration options. So for example, Radius or netconf at this point are not supported as a configurable option through the config backend. Some parameters obviously must be configured via the JSON configuration file. So for example, the server tag or the name, as far as the database is concerned, of each individual DHCP v4 and v6 server is not able to be changed on the fly through the configuration backend. So that is still going to be a modification that's going to be, or a change that will need to be made on the DHCP server itself. So one of the things that I like about the configuration backend is it allows you to create an extremely minimalist configuration. So if you're deploying new machines out into the field, and you don't want to have to do a whole lot of configuration locally. You don't want to have to pre-configure all of the pools and all of the subnets and all the networks and all the options. The configuration backend allows you to go in and set a very limited number of options, and then have all the rest of it pulled out of the configuration backend database. So the things you will need to configure on your Kia servers, and this, I'm making the assumption that you have a little bit of knowledge about Kia itself, and I apologize if I get a little bit too deep too fast here. But in the configuration for Kia, you'll need to pre-configure the server tag, which is the who am I. It's the name of the machine or the name of this server as related to the configuration backend database. The interfaces configuration, obviously, it's if your DHCP server doesn't know how to communicate with the network, then it has a really hard time getting to network devices to, for example, pull down the configuration. So your interfaces configuration needs to be done in advance. The configuration of the control socket, so the ability for the DHCP server to talk to its Kia configuration agent. Something new is the config control, and we'll talk about this in detail in a couple of slides here. That is, where is my config backend? Where do I actually go? Which database do I go to pull the configurator out of to complete my configuration? Obviously, you have to set the hooks to enable the configuration backend. The lease database, at this point, you cannot change the configuration of the lease database through the config backend, so you need to go ahead and configure that in advance. And then expired lease processing. That is something that is handled locally to the machine, and at this point is not configurable through the config backend. And I listed these earlier, are able to be obtained from the backend. So all of your global parameters, all of your option definitions, the subnet and shared network definitions, pools, and then options on those pools and subnets and shared networks are all going to be now available through the config backend. So this eases your ability to create this minimal configuration, which is going to be very similar across all your machines. Then you ship this thing out to the remote site. You drop it in place, you bring it up, and then it knows how to go out and get the rest of the information from the config backend. And once it's online, it's going to automatically go out and refresh itself off of, I'm seeing a note from Vicky that says my audio is bad, and I apologize. Vicky, can you tell me what's going on?
It's not terrible. It's just that you're having some dropouts. That's okay. Just keep going. And if it gets really bad, I'll just ask you to repeat yourself a little bit.
Okay, that's fine. And like Vicky said, at this point, because of the way that Zoom is configured, I cannot see the comments that are coming in because I'm using one screen at this point. So I apologize for not being able to. So Vicky, just please do break in and yell at me if it does get too bad. So all of this information is available in the config backend, and again, every time the server, when it hits that timer, it's going to go out, look at the config backend, pull in any changes that are made, and apply them. So you're able to once this machine is out in the field, you're able to take full control over it without having to open a shell or somehow move a configuration file and then reload a server. So the Kia control agent is the mechanism that you actually use to communicate with the Kia servers. It listens on a configurable TCP port. That is for basically a web-based or JSON-based management. HTTP, it can do directly. HTTPS, is available through a reverse proxy setup. And if you have looked in the Kia Administrator's Guide, you will see that Nginx configuration is documented, so you can go in and have all of this encrypted if necessary. Kia Control Agent also listens on a Unix socket per service. Now the TCP port that it's listening on is actually multiplexed between each of the servers. So when you talk to it through JSON on HTTP or HTTPS, you're going to need to specify which individual server, whether it be DHCP v4, DHCP v6, the D2, or the control agent. You're going to have to specify which you're talking to. The Unix socket is actually opened per service. And so you have a specific socket for DHCP v4, v6, and D2. The Kia control agent consumes and emits JSON. So that's something that is really handy because it is a well-defined mechanism of communication. The fact that it both consumes and emits is interesting because it's very verbose. A lot of times there's a lot of, I don't want to say noise, but there's a lot of braces and brackets and things that go by, and then only a few bits that are actually usable from the human perspective, but there is a tremendous amount of information available from the Kia control agent. Here is a sample, and the reason I'm talking about this Kia control agent is because you have to have the control agent working before you can actually use the config backend management through the web service or through the JSON service. This is an additional piece that is available through subscription, and I apologize for not having mentioned that first. The subscription portion is the ability to modify this over JSON through the Kia control agent. The ability to bring up a server using the config backend does not require the subscription service. It is a part of the freely available subscription, the freely available hooks that come with Kia 1.6. So if you want to deploy this, if you're able to modify your database, and you'll be able to use the config backend, just will not be able to modify it in the same way that you're going to see here. You'll have to have something that is actually able to modify the data from your own. So with this, again, you have the multiplexed TCP connection and you sockets that are available for each of the different services. The Kia shell is a piece of software that is included with the Kia distribution. It is built and configured with -- with shell option. This is actually going to build the tool that talks to the Kia agent over HTTP. It's not required. I'll actually show you a number of additional mechanisms that you can use instead of having to do it with the Kia shell. You can also use SOCAT, which is the ability to, from the Unix command line, communicate with sockets. And obviously this is used with the sockets that are opened by the control agent. You can curl, communicate with HTTP or HTTPS services across the net. So SOCAT you could use if you were running locally on the machine, and curl you could do from anywhere that you can do an HTTP connection. SOCAT and curl are readily available on most Linux, Unix, Mac, Windows distributions. So you can find these tools very easily. So to use Kia shell to communicate, you're going to use something along the lines of Kia shell, give it the host IP address or name of the server that you're wanting to talk to, the port on which the Kia control agent is listening, the service, and this is again the DHCP v6, or if you leave it empty, it is going to talk to the control agent itself. And then the last item is actually the command that is being executed or is being sent to the remote server. So in this case, we're running the config get option or command on the local host server where the Kia control agent is listening on port 8080, and we are specifically getting the configuration for the DHCP v4 server that is running on this machine. So as I said earlier, the output of the control agent is JSON. And it is JSON in basically a very raw format with no pretty printing. So it is, it's basically all one big huge line with lots of braces and brackets and things, which I find very, very difficult to be able to read. So all of these commands and all of the output that you're going to see in the samples that I give have been run through jQuery. So JQ and just telling it to do the print, so the dot, so it reformats it into human JSON. You can also run this through Python with the -m JSON tool, and it will also do the reformatting. So all of these, if you just run the Kia shell command as shown there on the screen, then you will get a single line of output, but I don't find that useful. So again, I run the post-processing. With SOCAT, so all three of these, I'm giving three examples, are the exact same command, just through the different programs. So with SOCAT, we're going to echo, and then we're going to give it the entire JSON string that we're communicating with the remote server, or actually in this case with the local server, because we're going to be talking to the socket that is at /temp/kia-dhcp.sock. We're going to be reading from standard input, and we're going to ignore the end of file because there's some oddities with the way that sockets are handled within Unix. And in this allows us to get back the answer to the question or the command that we gave without having to hang around longer. So we ignore the initial EOF, and then we read the data from the socket, and it's provided to see what the result was. So with curl, we can again do the same thing. In the case of sending a post, sending a header with a content type of application/JSON, and then the data that we're sending is actually the JSON command. You'll notice that it is formatted a little bit differently than the SOCAT, and again differently from the curl. Honestly, I will tell you that I like the curl the best because it gives me the actual JSON that is being sent. I don't have to worry about it, and it allows me remotely as opposed to SCAT. And so all of the symbols that are given in the Kia administrator's reference are able to be handed basically into curl by using by replacing what's in the option -D with information from the command reference. So it's much easier to copy and paste. And again, it's also much easier to script. Your JSON, you stick it in there where the -D is, and does the rest for you. So having seen how we communicate with the basic Kia server, now we're going to talk specifically about the config backend. The config backend, we're modeling here the Kia DP6 configuration file. That there's a couple of new things. So the first thing that's new is the server tag. And again, this is the name of the machine, or the name of this service. And I want to say the name of the machine. I keep saying that, but it's wrong, because this is specifically the DHCP server that is running on wherever this configuration lives. The V6 server and the V4 server, they should have different server tags, and they are going to be treated differently, obviously. To enable the configuration backend, you put in a hooks library that points to the MySQL_CB hook. And again, this is open source. This is available with the Kia 1.6 distribution. There allows this specific Kia server to go out to a database backend and pull its configuration from that backend. If you are going to want to JSON directly to the Kia server, then this is the piece in a subscription. This is the CB commands module, CB commands hook. And what this does is it exposes this API that we're going to be using in the samples here to talk to the Kia V4 and V6 servers. Now, _CB hook uses the config-control block to figure out how to talk to the remote database. So as you see in the config control section there, we have the fact that this is a config database. It is a MySQL database. The name and user, that's the name of the database on the SQL server. The user is the username. The password is obviously the password for that database. The host is the remote server IP address on which the SQL database exists. And then the port number is the port on which MySQL is listening for SQL communication. The other thing here that we see within the config control is the config fetch wait time. This says that every 20 seconds, this server is going to go out and query the database to see if there are any changes that have been made to its configuration. And if so, it's going to pull them down and apply them. And then obviously the ... down there at the end is all of the other DHCP6 server parameters as you would have on a normal DHCP6 server. Now, I said earlier that you could put a bunch of the configuration into the database and you didn't have to have it in the DHCP6 configuration. You can still have it locally if you want to, and again, during possibly a rollout of config backend, maybe there are pieces of the configuration that you're ready to move to the database, but others that you aren't. You're able to mix and match, so you will be able to have DHCP6 configuration options in, or server parameters in the DHCP configuration, and some of it in the database. So this is one of the commands. I'm going to go through now the commands that we're going to be using to talk to the database. And these are given in their pure JSON format. So to use these, you could either the curl section the snippet that I gave earlier and replace the -d with this specific text. Or you could go in and modify the Kia shell or to give it the options in the correct format. I do this because, again, it's just the easiest format to display, and we're not going to be dedicated to one option or the other, or one mechanism or another. So when you give this list commands command to a server without the config backend, you're going to get a number of commands that are available to you through the JSON, through the REST interface. When you turn on the CB command module, the CB command hook, you're going to have a number of new options added. They're going to be remote, dash, and then the actual command that's going to be executed. So in this case, we see that remote global parameter for delete, global parameter for get. All of these are new, and they are available only through the config backend command hook. So the server tags, as I mentioned earlier, they are the things that actually create the ability to group options and configuration bits together. So the first thing that you're going to want to do is you're going to want to create the server tags. So each server has exactly one server tag that is associated with it. Each object then within the database can have one or more, well actually 0 or more server tags associated with them. There is also a global tag of all that is associated with all of the servers. So you're going to be able to go in and set up configuration options that are specific to one machine. And then if you have some things that are deployed to every single machine in your organization, or that is served by this specific config backend database, then you're going to have a tag of all that is going to be applied to, again, all of the servers. So here is, to put that graphically, if you have objects with IDs and the server tags that are shown here, so we have 3 machines or 3 Kia servers, one called headquarters, one called backup, and one called remote. If I have an ID 101, this is a network or a subnet or a pool that contains a server tag of headquarters. It is only going to be applied to the server with the server tag of headquarters. you see the little green block. We were building a config file out of the blocks of the ID option, of the ID objects. So then we have an ID 102, again, a subnet network or whatever, and it has two server tags associated with it. And again, the objects can have multiple server tags, but the servers themselves only have a single tag. So we have the ID 102, which has a server tag of both headquarters and remote. In this case, headquarters and remote get those building blocks when they go out and they query the database. So now we see that headquarters has 2 bricks and remote only has 1. Then we have the ID 103, which is only has 1 server tag, which is backup, and that means that that brick is only applied to the backup server. Then we have an ID of 104, and it has a null server tag. It has no tags listed. And in that case, it actually is not going to be deployed to any config backend servers. This allows us to put information into our database, but not have it necessarily associated with the server until we're ready to turn it on, or maybe it's just for historical purposes. And then the magical all server tag. So ID 100 here has an all server tag, and so it is deployed to all of the servers. It doesn't matter what their name is. So in this case, we see that the configuration for headers is built from 100, 101, and 102. Backup is built from 100 and 103, and then remote is built from 100 and 102. So as you can see, this is very powerful in the ability to change the server tags. If we were to come in and change the ID 103 tag from backup to remote, the next time each of these servers would come out and look at the database, the backup server would then remove the 103 option, and the remote would actually pick up that option and enable it. So you're able to move these options, networks, whatever, from machine to machine very, very easily. So to create these servers, so I kind of lied. Here is a version of the Kia shell that I don't have the actual JSON listed here because the command, in this case, the remote server 4 set and the remote server 6 set, are not within the JSON configuration or within the JSON snippet. But what I've done here is I've created 3 servers, and there are actually significantly more. But this server, the first one, has a server tag of headquarters. We have a description associated with it so that we're able to find that and get, see it humanly readable. We're talking to the host 127, we're talking to localhost on port 8080. This configuration option is being specifically given to the DHCP v4 server. And the command that we're giving it is the remote server 4 set. Sending that through jQuery, again, to format the output. You see that we're giving, the first one is for remote server 4. The second one is remote server 6. The third one is remote server 4. The fact that we have 2 remote server 4s, the first one is for a machine called headquarters, and the last one is for a machine called remote. So in this case, we're creating databases, or we're creating individual server tags for a machine called headquarters and remote. Both of these will get the tags from, or the server tags related to all, but we're building machines at this point. So the output from this, and I only gave one of the multiple outputs because they, again, are very verbose. Again, it is in perfect JSON format. We see that the arguments, servers, we see the description, the machine at headquarters v4. The server tag was given headquarters. The result being 0 means it is a success. And the text result was the DHCP v4 server successfully set. So we're able to see that that machine is intact and that server tag has been created. And as soon as the machine is out in the field and it is given the server tag headquarters, it's going to associate itself with all of the other database items associated with the headquarters server tag. So now if I go out and I run my, again, back to JSON, my remote server 4 get all, and again, I'm passing it to the DHCP v4 service, I'm given back all of the DHCP v4 servers that are configured within our database, within this specific config backend, and we see the server tags associated with them. So we see the headquarters and remote servers, and also the descriptions that were given. So you're able in this way to kind of take an inventory of the DHCP v4, and again, there's a similar remote server 6 get all that you would pass to the DHCP 6 server that is going to give back all of the machines or all of the servers created using the server tags and the associated tags and descriptions. Okay, that's great. I've created some machines. Now I'm ready to actually create a subnet and put it out into one of these servers. So I go in, and again with my JSON, you'll recognize this from a Kia configuration if you've done Kia configurations before. Basically, it's a subnet declaration. We're giving it an ID of 100. We give it the subnet that's being defined. If we wanted to give it a shared network name, we could give it here. And then the pools that are associated. We have to close off all the braces and brackets, and I'll tell you that's a pain, but again, it's nice to be automated. And in this case, we give it the server tag of remote. So this is only going to be associated with the machine with the server tag of remote. And then the command that we're sending to the server is the remote subnet 6 set. And what we're going to get back is the arguments that the ID 100 at the given subnet was successfully set. So again, it's very easy to look at this and search through the JSON for result. And if it's 0, you know it worked. If not, then you're going to need to figure out why. Humanly readable text is there that yes, it did work. And we give back enough information that we know which subnet was created and what ID that subnet was on. We can then go back and query a given subnet. And if we know the ID, we can say the server ID 100. And then it will give us back all of the information associated with that subnet ID 100. We're able to then see what server tag is associated with which machine is this deployed to. We're also able to see all of the other options and pools that are associated with this subnet. So now you're able to go in and query the config backend and see what see what a subnet looks like based on the ID. You can do the same thing with a given server tag. So we want to see a list of all of the subnet 6 that are associated with the server tag of all. And this way, we're able to see that there are 4 IPv6 subnets, and then it's going to list them for us. The subnets, 101, 102, 103, whatever they are, and then all of the metadata associated with each of those subnets. So if you want to see the configuration for the server remote, you could very easily go in and go do a server tag all, then a server tag remote. You then have all of the subnet 6s that are associated with the remote server. You can create IPv4 option definitions. So if you've done IPv4 DHCP, then you know that there are vendors out there that have specific definitions that you need to create. Or options that you need to create, the options you need to define. And so what this is showing is that I'm able to create an option named foo. It is a code 222. It is an unsigned int length 32. It is not an array. There are no record types associated. It is a DHCP4 option, and it is not encapsulated. This is being sent only to the server called headquarters. Now, as I was looking over these slides, I thought to myself, this is kind of dumb because you don't really want to associate a DHCP v4 option definition with a specific machine necessarily. Most likely what you're going to want to do is create this with a server tag of all and all of your option definitions with a server tag of all. Then all of these options are sent to all of your servers, and you have a very common set of option definitions across your entire fleet of machines. So once you run this command, you get back the definition, the fact that it worked. You get back a 222, the fact that it was 222, it was created in the DHCP v4 space, and again, the result is 0. So yes, it worked. Congratulations. we're able to get that definition as well. So if we know that code 222 in the DHCP v4 space was created, but we don't remember what it exactly looked like, we're able to go out and query the server, and it will provide us back all of the information associated with that specific option definition. And I think that if you've done large deployments, lots of DHCP v4 servers, you might see how this could be useful instead of having to go out and modify a large number of configuration files and then restart a lot of servers. You just make these configurations in the config backend. They get slurped into the servers themselves, and you don't have to go out and do any of this manually on machines. So how do you move to the config backend? Well, this is something that's going to be interesting for everybody because it requires you to really understand your existing infrastructure. What you're going to need to do is you're going to need to go through your configurations for all of your currently deployed DNS or DHCP servers and look for common elements. So when you see common elements between a group of machines, they will be given a, you'll keep track of those machines and you'll put them in the server tags for that element. For things that you see across all of your networks, obviously the server tag of all. And I really see this as being a topic that I'm going to be doing in a future webinar. So I think that this is something that is very, very useful and will be very handy. So in a bit of conclusion, what I would like to do is recommend that everyone go out to the GitLab that we have set up for Kia. You can go out and look at, there's a label of config backend. You can look at any open issues. You can actually make recommendations. So if you see something or if you know a feature that would fit in either with the config backend specifically, pardon me, or with Kia in general, you can go in and open an issue yourself within GitLab, and it will be discussed within ISC, and it will be directly visible to all of the engineers. So with that, what I'd like to do is open this up to the questions and comments. I am going to actually turn off my screen share so that I can read the participant, the information from the screen here. So let me stop sharing. And let's see if I can figure out how to find the chat window. And so Vicky, since you've read over these, and I see that there are several of them that are rather long, is there anything specifically that you'd like me to talk about? Well, I don't hear anything. Can anyone hear me? Well, actually, I can't say if anyone can hear me because you're all turned off. You're all muted. Well, I guess I'm kind of at the end of the presentation. I apologize for not being able to.
We can hear you, Alan. Everything is going well. If anyone has any questions, you should be able to unmute yourself and ask a question, or you can go ahead and type it into the chat or in the Q&A section.
Okay, so Chris, I'm gonna read back through the information here. Okay, and I see that they're already being answered. Fantastic, already being answered by the engineers themselves. So the fact that is the DHCP server grabbing deltas or full configurations, and the answer was that it is grabbing deltas. Very easy to spin up VMs to handle increasing load. Again, clone, it's set up server tags, and they'll pull down the configurations and basically clone themselves. And so I see there was a recommendation of JSON viewer .stack.hu. I'm not familiar with that, but I will take a look at it. So thank you for that. Actually, I think that may have been Tomek or Thomas or somebody named Tom said that. Any other questions or comments? Well, hearing none, I will give you back 9 minutes of your day because it looks like it is 10 minutes until 2 my time. Hope everyone enjoyed this presentation. If there's anything that we can do for you, please let us know. And I do think that the config backend is going to really open up some fantastic things as far as managing DHCP servers.
Alan, thank you very much. Oh, sorry, there is one question that just came in, but I think Vladek just answered it.
Okay, fantastic. This is a great thing about having a fantastic team because, you know, me being able to do this presentation and you guys get answers from engineering while I'm doing it, that's a win on everybody's side. So with that being said, have a wonderful day, everybody, and we will talk to you at the next one. Bye-bye.
Thanks to everyone for participating. Bye now.